will also discuss how quantum is becoming practical and relevant to industry. My name is Sridhar and I'm happy to have you guys for another interesting discussion in the field of quantum. So the interesting topic which we're going to discuss today is how Quantum X Labs are building their AI-based quantum error correction platform using NVIDIA CUDA-Q quantum error correction platform and GPU acceleration. The most important point here is how are they evaluating the decoder by using something called a simulated toric code error data using NVIDIA GPU in an AWS environment. Well, technically the workflow is a quantum processor first executes a circuit, then a physical qubits experience noise, 3 error syndromes are measured, 4 the decoder predicts the most likely error patterns, and finally appropriate error corrections are applied before errors accumulate. Now what does it technically mean? The quantum computers cannot simply read out the errors directly. Instead, measurements are done to produce syndrome, and these syndromes have information about the errors and where did they occur. Now, why is this topic important? Because the quantum error corrections are the roadblocks for large-scale fault-tolerant quantum computers. Now, to execute useful quantum algorithms, systems must first continuously detect errors, then decode those errors, apply corrections, and finally complete all these steps in the stipulated qubit coherence time. Who should be listening to this podcast? Quantum error correction researchers are the key people here, quantum software developers, enterprise leaders evaluating quantum roadmap, and then the most important is companies developing the quantum processor. What value will this create for businesses? 1. Faster quantum error correction research. 2. Supports fault-tolerant quantum computing. 3. Demonstrates AI for quantum system operation. And 4. Accelerating the quantum software ecosystem. Now, what should businesses and researchers do? They should first do an MWPM decoder versus AI decoder where they benchmark them and then run real experiments on syndrome data, but not only on synthetic data. 3. Measure your accuracy, latency, and your GPU-CPU cost. And the most important point, which is test your performance under correlated and drifting hardware noise. Let's look at the event article index, which talks about the topic which we have looked at, which companies are working towards it, what is the hardware which they are using, what is the maturity level of the hardware, in which industry they are applying this particular topic, and what is the business relevance to this particular topic which we discussed. Thank you everyone for listening to today's podcast. If you found it useful, kindly like, share and post your comments. Until next time, keep learning, keep building, and keep exploring the future of quantum. Thank you.